Hello, welcome to another video on how to solve ODEs in MATLAB. So today we want to look at another problem where we have, in this case, two ODEs and one algebraic equation. So it's for a non-isothermal batch reactor described by this simple mass and energy balances with the kinetics described by something similar to the Ionospheric equation. We have the initial condition for the concentration and for temperature. So we want to solve for the concentration and temperature with respect to time. So we want to see how the temperature and the concentration evolve over time. So let's see how to do this in MATLAB. So um, first, what we need to, here this is optional, but clear on CLC, close all. It's just a way of clearing all the the variables that you might have defined that we have in MATLAB. So, but the first thing, using this approach, so this is a different approach to some of the videos I made earlier on how to solve ODEs in MATLAB, where you could use an anonymous function to define your function. But in this problem, I'm using a different approach. So where you have to we have to define the function as a local function. So what do I mean by that? Here, first we define or you specify the time span. So t span, you're running from 0 to 1. And then the initial condition for the two variables. So it's specified as a vector. So you have 1 is for concentration and 150 is for temperature. Okay? And then you define the ODE system. So t comma y. So you are doing that with respect to time, and then y is like a matrix that stores those vectors of your result. So you call OD45 and then you call the function. So at reactor model, so that this is where you are calling the function you are going to define later. And why you are defining this function later, I'm going to explain in a minute. So T span is the how long you want to run, the time span, so between 0 and 1. And why not is the initial condition that you previously defined here. Okay, now we extract the result. So y is the concentration is the first vector, and temperature is the second vector. So that's why it's basically the second and the third vector rather. So 1 and 2, because the t will be the first. Okay, and then the figure, you define the figure function, then you plot the concentration. This is just plotting a subplot. So you want to have two plots as subplot combined. So the first one will be the concentration, and the second one will be the temperature. So as you define here. Then you define the function. So the function that you want to run is the reactor model. So that has the three equations that I showed earlier. So, we have one algebraic equation, so K, and we have the two differential equations, these two. Okay. Now C is the concentration, which is basically the first state variable. So Y1, and T is the second state variable, Y2, in the vector that you define in the ODE system. Okay, so in the vector here. Now, once you define your equation and the differential equations, you return dy dt as a vector of those differential of those derivatives that you have, dc dt, dt dt. If you have more, you return all these derivatives as a vector, and then end the function. So this is how you define function in MATLAB. Function, your function name, dy dt will be your function name, and this t here is even though the t is not used anywhere. This is one thing that you should note. The t in the function is not used anywhere, and you might get a warning from MATLAB that, okay, you've not used t, that small letter t here in the equations. But we can ignore the warning, or you can just put something like that. You can put this symbol. So you put that symbol, then it's like a placeholder. So don't worry about what is there. So that's another way we can treat that. So if you then run the code, then that generates the profiles of the concentration with respect to time and the temperature with respect to time. So that's how you can solve the problem in MATLAB. So the key thing here is that local functions should come last. Remember that. So when you are not defining the function as anonymous function, if you're using this approach and you're defining a local function, the function will come last. Why? Because MATLAB um, will first execute scripts. So scripts must be above, and then all the functions must be below. Although the function is called here. So the ODE 45, which is the solver, calls the function here. It doesn't mean that the function will be run last. No. This code here, they are executed after the function has been executed. So ODE 45 calls the function here with this at, and that it runs it, even though it is placed at the back, at the back of the code, but it is executed here before the plotting of the result. Okay, this is very important. So the reason is because you have to, in MATLAB, script has to come first. You need to run the script, and then you put the local function uh, at the bottom. Script, then function. So you cannot do script, function, and then have another script. No. So once you define the first function, everything else has to be function. So all the functions must be put together at the bottom, and the script will be at the top. Okay. So even though you can call those functions within the script. Okay. I hope that makes sense. So that's it for this video, and I will see you in the next video. Bye bye.